गुड मॉर्निंग सर।
गुड मॉर्निंग सर।
कैसे सर?
गुड मॉर्निंग एवरीवन। बस बढ़िया।
सो स्टार्ट कर सकते हैं सर?
Yes, we can start.
Okay. So good morning to all of you. So we have come to an end of this FDP, and we come to the last day of this FDP, and we have today's session with Professor Vijayan Singh sir. So I would just like to introduce sir first. So Professor Vijayan Singh sir is an associate professor and head department of information technology at Indian Institute of Information Technology, Allahabad, Prayagraj. He received his PhD degree in the area of machine learning and signal processing from the Albag Educational Institute, Agra, in the year 2008. He has over 18 plus years of experience in academics that includes teaching and training and research and development and continuing. He has also worked at Department of Electrical Engineering, IIT Kanpur, as Senior Project Associate. ECOL, Polytechnic Federal, EPFL, Switzerland, as visiting research faculty, and was consultant to Pitera Sampionia Foundation, Jakarta, 2012, for course curriculum development in IT and allied areas. He has also visited Dubai, Oman, Abu Dhabi, Malaysia, Russia, and Scotland for education, research, collaborations, and providing consultancy. He has been conferred with the 50 Fabulous EduTech Leaders Award at the 8th World Educational Congress, Mumbai, in the year 2019. He has developed various intelligent systems, softwares for Indian industries, research organizations like TVS Motor Company, BARC, ISRO, SAIL, IOCL, NPTEL, etc. He has transferred technology to TVS Motors Motor Company, Hosur, India, for testing of two-wheelers engine during assembly line based on acoustic data analytics in the year 2009. He has successfully deployed a system under Government of India and National Science Foundation, USA, a sponsored joint project 2013 to 15 for classification and protection of wildlife and human, virtual fencing, gunshot detection and localization using IoT devices, and sensor communication networks at Pana Tiger Reserve, Madhya Pradesh, in collaboration with Indian Institute of Science, Bangalore. Wildlife Institute of India, Dehradun, also the collaborator, the OU State University, then Cornell University, and the University of California, Los Angeles. He has also authored over 75 publications in reputed international journals, conferences, proceedings, and book chapters, and edited one book. Currently he is serving as Vice President, IEEE Computational Intelligence Society, UP section, and advisor to Network Power Solution Enterprises, New Delhi, India, and collaborator to Nav Ajna Technologies Private Limited, Hyderabad, India, and consultant to Pragmalytics Technologies, Kochi, India. So we welcome you, sir.
Thank you, sir. So can we start now?
Yes, sir. Yes, sir. Definitely.
Okay. I think my slide must be visible.
Yes, sir. It's visible, sir.
It's visible. Okay.
Yeah.
So thank you, Namanji. Thank you so much for the introduction. And this is the slide which I have prepared for today. That is the IoT data analytics and applications. So I suppose all of you must be knowing what is IoT, what is data analytics, and what is applications, because this is the last day of FDP. So you can also interact with me. You can ask questions, as many as you want. Maybe some of them I'll be able to answer. So in between also you can interact with me. Okay. Otherwise it will be only one-way communication. So you are free to ask.
I have just muted them, but they can write their question in the chat box.
Okay, okay, that will be good. Let me open the chat box.
Till now, there is no one query.
Okay.
So,
okay. So in between, if there is question, so please stop me, sir.
yes,
okay?
sir. Yes, sir. Definitely. I will tell you, sir.
That will be good. Okay. So let me start with introducing my laboratory here at IIIT Harvard. That is the deep learning laboratory which we have established here, and it comprises of many. We are doing many applications for different industries. So pattern recognition, speech processing, information security. So all kind of latest frontier areas of research are there. And this is the fair use disclaimer. So the presentation contains few information, material, images from the web resources, journal papers, etc. under fair use policy. So some of the material have already taken for the education purpose, and mostly is my own content. So let me start with defining what is intelligence, what is artificial intelligence, what is machine learning. Then I will slowly come to the IoT and then the applications, including the data analytics part. So whenever we talk about data analytics, we have to talk about the intelligence. So intelligence is the ability to perceive or infer information and to retain it as knowledge to be applied towards adaptive behaviors within an environment or context. So that is the intelligence. Like we said, like humans are intelligent. So what is human intelligence? It can be defined as a general mental ability for reasoning, decision making, problem solving, learning and retaining information. Intelligence combines cognitive function like perception, attention, memory, planning, and language for communication. So we have some knowledge, we have acquired some knowledge, and based on that knowledge, we want to try to apply that knowledge to those areas which we have never experienced earlier. So what is artificial intelligence? So artificial intelligence was whatever human intelligence is there, we want to convert it in form of artificial thing, or maybe using computer, we want to apply the intelligence. So that is the intelligence exhibited by machines and softwares. It is also the name of academic field of study, which studies how to create computers and computer software that are capable of intelligent behavior. John McCarthy in 1955 defines it as the science and engineering of making intelligent machines. Then what is machine learning? Arthur Samuel has defined it in 1959. So that is the field of study that gives the computer the ability to learn without being explicitly programmed. So that is the machine learning, is a, we can say, subset of artificial intelligence, which gives us this facility, like computers can learn even without we have given examples of the same problem. So Tom Michel in 1998 again defined this machine learning by a computer program, or we can define it like a computer program is set to learn. So because now we have to define the learning. So computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task T as measured by P improve with experience E. Then we say that it is that the machine is learning. So computer program is set to learn from experience. So it means we have to give some data set so that it can gain some experience with respect to some class of task. Why we want to do this? Because there should be some clear-cut objective goal. And then we have to evaluate the performance P. And then what we are saying that with respect to time, if this performance measure is improving, we are getting better and better result, then we can say that the machine is learning. So now there are three things. One is the experience E, class of task T, and performance measure P. Okay, so performance we can say, like if we want to predict, then what is the prediction accuracy? If we want to classify, what is the classification accuracy, and so on. So from where we can get this experience? By the data set which we are collecting from the real life environment. And what are these possible type of classes of task T? So the problem can be of classification problem, can be of regression or functional approximation problem, maybe clustering problem, maybe pattern recognition problem, maybe time series analysis, maybe anomaly detection, maybe continuous monitoring for something. Then performance measure can be measured in terms of accuracy, precision, recall. Okay. So I hope this classification, regression, all these type of problem you already must be knowing. And past speaker must have informed you something related to them. So coming to what is the taxonomy of machine learning, we say that there are a couple of learning algorithms. We categorize them in form of supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? We say that for all the input data set, there is also some output data. So we know if this is the input, what will be the output. So it can be written mathematically in terms of x and y1, where x is the input, y is the output, then x and x, yn. What is unsupervised learning? We have only data set and we want to cluster them. We don't have what is the output class. So here we have the data set in form of x1 to xn without any label. What is reinforcement learning? So reinforcement learning is learning from the system and then predicting the future values. So state, action, then feedback from the system. Whatever you are performing, a small child is walking, then if he is not able to properly walk, then he will learn from this feedback that if child will fall down, then he will get some hurt. So then child learn from the existing system by taking the feedback and then update that we have to walk like this and then perform many things. So this is majorly these days people are applying these type of reinforcement learning in robotics, robot motion planning, autonomous things. So let me take this example for explaining you what is a classification. Although you must be knowing that the first example is depicting the OR logic. So OR logic means if we have 2-bit data set with us, then 4 possible combination will be there, like 0, 0, 0, 1, 1, 0, and 1, 1. So if we denote it on the Cartesian axis, then we can say that for 0, 0 value is 0, for rest 3 value is 1. So this problem, if we can draw a vertical line like this, then we can say with a slope, then we can say that above this line, all the class value is 1 and below this line, all the class values are 0. Okay. This line can vary from 0.00 to 1,0. Okay. So anywhere we can draw this line and we can say that it is able to classify this data set in class 0 and class 1. So this is a kind of classification problem. So what we are saying that this problem is linearly separable problem. Coming to next example, this is the example of AND. So for AND, we have 3 0 for 0 0 1 0 and 1 1 for 0 1 and 1 0. So all these 3 points are 0, but for 1 1 the output is 1. So it means again we can draw a line, then we can classify into 2 class 1 and class 0. So again this is a linearly separable problem. Coming to the third example, that is the exclusive OR problem. For 1 0 and 0 1 the output is 1. For others, the output is 0. So this problem, we cannot draw a single line, straight line in order to classify into class 1 or class 0. Because if we are drawing line from 0 to 1, there is 1 0 remaining, which is misclassified. If we draw line above this 1 1, then again this 0 is misclassified. So what is the better way to model such type of problem is to use some hyperplane. In this case, we have used some ellipse. So this, inside this ellipse, we can say that it is class 1 and outside this, we can say class 0. So this was the time, so 1980s, this machine learning concept was failed and it was known to be the death of the neural network when people tried to solve this exclusive OR problem by using the straight line, and then they said that it cannot be solved. So that was the time when this neural network was known as the death of the neural network. So again, then people researched and then they found if we can draw a hyperplane, we can classify this exclusive OR also. And there they have also suggested that in place of using a single neuron, if you can use a network of neurons, then that will be able to classify the whole system. Okay, so this is a brief history I am telling. Now these are some popular supervised learning algorithms like backpropagation algorithm, Bayesian classifier, decision tree algorithm, random forest. nearest neighborhood algorithm, support vector machines. Coming to unsupervised learning algorithm, clustering algorithm like k-means clustering algorithm, density-based clustering, hierarchical clustering, self-organizing maps, heuristic clustering methods, adaptive resonance theory, then expectation maximization algorithm, then principal component analysis, then independent component analysis. So these two principal component and independent components are widely used for feature extraction purpose also. So this is just one example. We have created one software for Bhabha Atomic Research Center. So some glimpse of that. So you see the right corner in the fourth quadrant, there is a neural network architecture. So what is the benefit we are getting from this neural network kind of thing, machine learning thing? We are modeling for the data set, for the real data set, and then we are using that model to predict for the future values, either for classification, regression, functional approximation, or something else. Coming to the third quadrant, you see it is a kind of clustering. It is representing. So there are different clusters. So, but there is one point, brown color point here, which is not belonging to any of the clusters. So what does it mean? That may be either noise or that may be some anomaly. So normally this anomaly detection is a very interesting problem. So people apply this type of technique, clustering technique, in order to detect whether there is some anomalous behavior or not. Like intrusion detection system. So what we want to observe is the anomaly. Okay. Like home monitoring system. So we want to detect the anomaly, something which is not normal is happening in the home. Okay. Then these are some of the other graphs. Let me take another example for classification so that you can understand it in better way where we practically apply these type of technique. So this is the example I am taking, which we did for long back for TVS Motor Company. So they used to test the this engine of a bike, okay, two-wheeler. So what left hand side, if you see, that is the engine test rig. So that is there during the manufacturing. They make this engine and then they test that engine. So they put it on this test rig, and then there are some operators they use to start this engine. They used to hear this audio acoustics, and then based on that they used to decide whether this engine is okay or not okay. If it is okay, then it will further go for the final integration with the overall bike. If it is not okay, then it will again send back for further improvement. So what we did for this, because the operators were doing they were hearing the sound of this engine, and then based on that they were deciding whether this engine is good or not good. So we have replaced the twin system by the twin system. So what we did, in place of ears, we have replaced it with the sensor. And what are those sensors? Sensors are like our ear. So we can use microphone for hearing, then integration, and then integrating all these analog data to the digital data. So we use some data acquisition system, DAC card, which we are converting this analog data to digital data. And then we have developed our own intelligent technique in order to differentiate. Then we were recording all these acoustic. And then based on that, we were actually predicting whether this engine is good or not good. So actually we were doing the classification task in which we want to give the certificate to a particular engine, whether it is good or not good. And if it is not good, then we were also telling, because now we are using our machines, intelligent machines, and we were also predicting like this is the possible type of fault in this particular engine. So we have actually detected around 6 to 7 possible type of fault in this. And then we have also told them that there are some engines which is good and there are some engines which is very good. There also there are two categories of good. One is good and one is very good. Then they told that some of the users, they gave us feedback that whatever mileage we are telling them is the highest mileage, they are getting even more than that because of the very good engines. Okay. So because it is manufactured by materials and many other things, so sometimes it performs even much better as the standard is. So this is one example. So what we did, we have converted the whole human intelligence into the machine intelligence. Then we have integrated the sensors. So now I am introducing this concept of sensors here. Okay, because in IoT, Internet of Things, actually everything has to be considered as the sensors. Before going further, I will open this report, that is Future of IoT report by FICCI. I think most of you must be faculty members. So always whenever we want to do something, then we should always refer to the latest reports of the government of various industries. So that helps us a lot in order to understand a particular topic. So coming to future of IoT, then I will go back to my presentation. So this is a report published in, I suppose, 2020 only, very recent report, maybe the April month. Okay. So I will take some example of this. So what are the enablers of Internet of Things? Okay. So this is the recent report. So it means that will be very much useful in order to understand the latest thing related to IoT, and this is related to India. So what is the enablers of IoT? This is worldwide concept, enablers of IoT, that is the decrease in sensor and electronic cost. Okay, that's why it is increasing. Increase in computing power, like increase in transistor count in billion. On-demand cloud computing facility is also there. Prices are decreasing. Then decrease in cost of connectivity. So earlier in 2014, it is 0.47, 1 GB data, now it is 0.04. So that's why it is, they are the supporting thing which is enabling the Internet of Things. These are some of the slides which is telling that IoT market is increasing day by day. So it is giving you emphasize that why we are conducting this workshop FDP on this IoT thing, because that is the future. And there are many industries, many countries who are putting lots of money in this particular area. So it means there is a bright future in this particular area. So you see connectivity is 5%, IoT professional service 27%, platform application service 68%. So global IoT market revenue by 2025 will be 1.1 trillion US dollar. So in 2017 it was 7, in 2025 it is 25. So it means there is a huge potential, financial potential also in this particular area. So these are some IoT spending worldwide in billions. Logistics, then manufacturing. So majority, you can see that IoT is being applied in manufacturing because people want to actually monitor the overall manufacturing process. Then consumer IoT, then transportation, although this transportation will definitely increase day by day. Utilities, asset management, smart home. Then Indian market size, IoT market size in India is around 9 billion US dollar. Then Government of India initiatives on IoT. So there was one draft IoT policy came in 2016, and this is 2020. The national committee came in 2018. So it means government is continuously trying to give roadmaps and suggestions and regulations for moving this IoT direction. Then IoT Center of Excellence by NASCOM. I am just reading some of the highlights. You can go through it in details later. Then key digital trends shaping the future, that is the digital twin. So what is a digital twin? I have already explained, like from creation to users to services. So earlier the business were doing their production system. Then what we were doing, we have actually given them the computer systems with some software, standalone software. Then people were applying those machines. Then they were actually very much helpful in order to do this creation task or the basic task. Then the uses came, then production ERP system came, consumer uses of goods. Then what was the virtual world, what we were doing? Then we have integrated the sensors, data collection, condition monitoring. So this project, this TVS Motor project comes under conditional monitoring. Then intelligent connection of machine and personal, sensors, big data collection. And then coming to the services, it is maintenance, repair, overhaul. And now we are talking about big data analytics. So what we want to actually replicate this physical world by using the machinery world or virtual world. So whatever we were doing by the human intelligence we were doing, now the machine will do the same task. So that's what comes under this digital twin. Okay. So now there is a concept of fog and edge computing. So it says that earlier the concept of cloud computing came. So cloud computing means you are integrating everything to one system. because of maybe privacy, maybe the data security. So people have thought that in place of putting everything on a one system, one cloud, if we can have different fogs, and then connecting the local devices there on a local fog will be better solution as compared to everything connecting to one single cloud. So this fog computing is again increasing day by day. Then 5G and IoT, this 5G will definitely very soon come, and then it is going to actually boost this IoT techniques. Virtual, augmented, mixed reality applications. Okay, so whatever we are doing intelligently comes under this. Then IoT security. So definitely, if the data is there, then there are two types of problem. One is storing everything on the cloud, then storing some part at the local places. Okay, so distributed manner we are storing the things, because data storage is also a big concern. Then IoT value chain, there are many companies who are actually involved in this, and these days, okay. Then this is the last one, that is the how future trends are shaping key sectors. So this is Internet of Things, transport and logistics, consumer IoT, utility, smart home, everywhere this is being applied, the concept of IoT. Then smart manufacturing is again a major concern. These are the following maybe the key use cases for smart manufacturing which is available. That is the smart products, smart equipment, smart maintenance, smart materials, smart metrics, smart workforce. So everywhere we are saying that it is smart, smart, smart. So how can we very much smart? If we have all the data sets, then we can be smart. And based on that data set, we can apply that data set for our use. Okay. So, okay. Then this oil and natural gases. So this is where this IoT is very much applicable. So we did one workshop for ONGC. So they are trying to explore at different places where they can get the oil. And then oil pipelines are also there. They want to monitor that pipeline because it is a long, very long range pipeline. So it is very much difficult to monitor everywhere physically. So IoT applications is very much applicable to this oil and natural gases. So somewhere if some leakage is there, so IoT devices we can use some devices in order to monitor them. And then everything has to be integrated in one place. So well drilling is another problem, because they want to drill the well so that they can detect whether there is some oil or not. So maybe they can put some sensors, then they can actually do the survey of a particular geographical region. Then transportation is there, storage is there, then monitoring is there, then smart city concept is there, smart government, smart living, smart people, smart mobility, environment, economy, everywhere you can use this IoT. Then this is the some references. Okay, so why I have taken this example of FICCI report, recent FICCI report of 2020, because it is giving you some idea, like government is also involved in developing regulations and supporting people so that people can work in this particular field. Now I will take another example which we did for Panna National Park. So here you will understand what exactly this IoT, what is this network, how smart monitoring is possible. So this is example where we are making our forest as a smart forest, and same concept can be applied for smart cities also. So what is the scenario here? So this was the Panna National Park located at Madhya Pradesh. So there is one forest here. This forest, what we did, what is the problem there? First, we should understand what is the real life problem, then only we can provide some solutions. So the problem of Panna National Park was they are having lots of wildlife, especially the tiger, because in India or abroad, everywhere this particular tiger, they are decreasing, the number of tiger is decreasing day by day. So in India, this was also a major concern. So what they were doing, they were monitoring this particular tiger. They are having many tigers, and for every tiger, what they were doing, there are forest guards, around 4 to 5 forest guard with one vehicle. They used to track a particular tiger, because tigers, they are residing in this forest. Why they want to track it? So that they can monitor the tigers. Also, they are along with the tigers nearby places so that poachers cannot kill them. Okay, because smuggling is also there with respect to tigers. So that they can safeguard from the poachers, because normally poachers go inside the forest, they kill the animals, bring with them. And also what were the things which they can carry with them is the only the small stick. They cannot use gun. So tiger can eat the forest guard, but forest guard cannot kill the tigers. So that is the rule. So what happened? Normally tiger stays a particular region. So they monitor, they move around some particular fixed region. So that is helpful for these forest guard in order to monitor these tigers. And what was the techniques they were using for this? They were using some collar, and the weight of that collar was 2.5 kilogram with some battery. So RF antenna they were having, and this was the RF communication. So this tiger was moving here and there, and based on this RF signal, they were actually around this tiger in order to monitor that tiger. So there are n number of tigers, then there will be n number of teams, they were monitoring this type of thing. Even then, these poachers were trying to come inside the forest, and they used to kill the animals. Not only tigers, but other animals are also there. So there are elephants, there are small animals also, okay? Leopards are there. So what was our target? Our target was to monitor this huge area so that we can actually monitor the tigers. What are they doing? Where are exactly they locating? Can we differentiate different tigers also? And then also at the same time, we want to safeguard these wildlife animals from the villagers. For solving this type of problem, what can we do? We can actually deploy sensors everywhere, because we want to monitor them. Manually, this task is not possible for us. So what we did, we have deployed everywhere electronic modes. This was given by Ohio State University. They are having their own startup, Samraksh Technologies. So they have given us this mode, and then what we asked them to design in this mode so that we can collect these acoustic data. We can also collect the temperature, humidity. We can also collect some other data set. So what happens? Then we have divided this whole task into different objectives. So what we did, like some poachers are coming inside the forest, and he will definitely fire a gun. So if some poacher is firing a gun, then based on these emotes, we can actually detect the sound if some sound is there. Okay, so there is a normal condition, silent conditions. Then after that, immediately there is some gun firing. So it means there is a change in event. So we should be able to detect this change in event. So what we did, we programmed these emote in such a way that if there is a significant change in the continuous event, then you should capture that data. Otherwise, no need to capture. Otherwise, what will happen? Every time this will capture the data set, then it will be a huge data set. Then data management is a big problem than any other problem. So what happens if some poacher is coming inside the forest, he's firing a gun, then immediately whosoever the modes, nearby modes, they will capture this data set. Then they will transmit this data set to, suppose, a guard station. There is a guard station. Everywhere there are modes. There is a water body, pond is there. And pond is very important as far as forest is concerned, because these animals, they used to go to the pond in order to drink water. So that is the region. Then what we did, we have also deployed one new technologies which we have developed based on fiber optic cable. So we have covered this water body area by our fiber optic cable, and this signal we were collecting for fiber optic cable, and based on that signal we were actually classifying that who is coming to this water body. Then around 4 cross 4 kilometer area we have covered using this fiber optic sensors or fiber optic cable with our own technology. And along with this, there were emote sensors, and the distance between these emote sensors, because we have deployed it in a grid format, and the distance between two sensors were around 200 meters. So we have tested in the forest that up to 1 kilometer we can actually detect, we can communicate, these two modes can communicate. But if the whole area is blank, but if there are lots of trees and other thing, it's very communication, packet drops were there. So then we decided, we have experimentally decided that this 200-meter is a good enough distance in order to monitor this particular forest. What happens, the nearby sensors, they were collecting this data. If some gunshot is there, they were sending it to guard station or the central server. Then that central server was deciding whether this is a gunshot or not. If it is a gunshot, then we have another technique, that was the fiber optic cable. Then based on that, we can actually triangulize and localize where this event has happened. This was one task. Second task, because near to 4x4 kilometer area we have covered by using this fiber optic cable. So if somebody is crossing this particular boundary, virtual fence we can say, then immediately this fiber optic signals we were processing, and then we were predicting whether a person has crossed this or animal has crossed this. And if suppose animal is crossing, and many times this also happens that animals are moving from the forest to the villages, and then they used to kill the humans. So that is also a big problem. So we were detecting whether a person has crossed, whether an animal has crossed, and if animal has crossed, then what was the animal? Whether it was tiger, whether it was leopard, elephant, or what else. Okay, so this we are giving you one glimpse of IoT network with sensors and communications and then the intelligent techniques. So sensors are long back concept. Sensor communication is also long back. Machine learning is also long back. So everything we are now integrating together in order to monitor this. And because we are continuously monitoring this whole system, it means this system is intelligent system or a smart system, which is very much helpful for day-to-day living. So any question in this? Okay. So it means we have started from the instrumentation and now we are moving to the embedded analytics. Okay. So moving further, so earlier we were doing this task at the guard station, then after that we programmed each emote, because that is very light, each emote, and then each emote was able to detect whether there is a gunshot or not. Okay. Otherwise, what will happen if suppose thousands of sensors are there in this forest, all will transmit the data set to the guard station. Then there are different type of errors they can occur in the system. Then there will be decision making. Then there will be some other thing. So instead of sending all the data set, then decision making, then other thing, we can actually process it locally, and then we can only send the decision to the guard station for further action. Okay. So what does it mean? Earlier, we suppose this guard station was the cloud, and now you can locally create local fogs for a set of devices connected to that particular fog. So this distributed manner, if we do this type of management, data management and processing management, then that will be always better as compared to the central cloud-based services. So from instrumentation to batch analysis, information fusion, now we want to talk about embedded analytics, where we want to put our intelligence in the embedded systems, and then they will automatically do the analytics. So these are the major concerns related to IoT. One is the lots of dimensionality data leading to big data. So whatever IoT systems are there, they will definitely continuously give you the data set, and then it will be very much difficult to deal with such type of data set, because that is a big data set. Many data in sequence time series data. Suppose there are different type of sensors we are integrating to our system. So definitely they will actually generate lots of data, time series data. And then it will be very difficult to handle this type of data. Then fusion, integration, complexity, different type of devices, different type of sensors, how to integrate them, how to do a common decision making by integrating all the devices. Then real-time decision making, control, forecasting. So this is again a very important concern, because like this forest example, if you see, when the forest has just entered the village, our system should immediately tell the guard station that somebody has entered that particular village, which we did. And so that immediately they can take control of that particular situation or area, and they can actually get rid of these poachers. Otherwise, what will happen if it is not real-time decision-making process? Then poachers can go inside, they can do whatever they want to do, then they can go outside. Then you are getting the result or the recommendation, then that is of no use. So that way, that is also a major task, that is the real-time decision-making. Some gas leakage is there in the oil, because there are many cases in oil and natural gases companies. Lots of blasts are there. Recently, it was there for ONGC also. So they are facing huge loss in this particular area. So if they are using this IoT kind of system, then they can easily monitor, and then they can also perform this real-time decision-making and control. Then security and privacy is also a major concern, because all these data set is continuously coming, then securing the data set, and also if we are applying it for humans, then the privacy is also a major concern. So these days people are developing lots of algorithms, even machine learning algorithms for privacy preservation, okay, unbiased or privacy preservation, security based. So these are some of the data pre-processing technique, like data standardization, denoising, filling missing values, dimensionality reduction. So dimensionality reduction is always a major concern and very much useful concept for any type of analytics. What happens, suppose continuously all the data set is coming, then processing all the data set is very difficult. Okay, you cannot store all the data set. So long back somebody asked that why you want to convert analog data to digital data. So we can answer anything for this, but the correct answer is because analog data, if we want to store, then it will be very much difficult to store all the analog data. That's why we want to reduce the size of the data set, and that's why we want to convert it from analog to digital for further processing. It is not like because computer process digital data, that's why we want to convert analog to digital. The reason is because we cannot store that analog data. That's why we are working on the digital data. Okay. And if you want to store the analog data, then huge databases are required in order to store that. And if you are having huge databases, then it will be very much difficult to process that huge databases. So this is always recommended that you should apply this dimensionality reduction technique. So whatever you are capturing from the real world scenario, you should always reduce the dimension of a particular data set. Okay. You should also be able to compress the data set. So we have already named one algorithm, that is principal component analysis. People use it very widely for this dimensionality reduction task. Okay. So there are many softwares, many codes, all these things, whatever I am teaching, I am telling, it is available. The codes will be available on GitHub or on the internet. So you can actually try with them. Then coming to the volume reduction. So these clustering algorithms are also very important because you want to reduce the volume. You have a big data, you are having trillions petabyte data, then it is difficult for processing those data sets. Then it is better to reduce volume as well as reduce the dimension. When we are saying that we want to reduce the dimension, it means we want to reduce the number of variables for a particular problem. We want to only consider those variables which are actually contributing to real life decision making. We want to ignore those variables which are actually not contributing, but we cannot know initially that these variables are actually contributing in the decision making process and these variables are actually not contributing. Okay. So what happened? We have to apply different intelligent technique in order to detect this, whether this variable is important or not important. So maybe decision trees can also be used in this type of decision making process when you want to decide which are the variables in a particular data set which are very important for decision making process. Okay. So from top root node can be considered as the most informative variable. Then coming to the left next level of node, then second next level of node. So it is in the reducing importance. Okay. Volume reduction, we have already discussed that clustering algorithm can be used to cluster the whole data set. Then we can pick samples from each of the clusters and then we can apply this supervised or unsupervised kind of thing. Feature extraction, there are many techniques in order to extract these features. Okay. So I have just taken this. Okay. Coming to this time series analysis, that is a major part of this today's presentation. So we have sensors deployed everywhere, IoT sensors, Internet of Things. So everything is connected to the internet. Everything is having IP address. Everything is, you can monitor, you can communicate. Okay. So if suppose you are deploying sensor at some place in some smart city, then what will happen? It will continuously generate the data set. So that data set can be considered in form of a time series. Okay. So what is time series? Time series are observations on a quantity or random variables collected sequentially with respect to time. So time series data. Data collected with respect to time. Many data collected with respect to time. That is multivariate time series. Univariate time series, single data collected with respect to time. Okay. So for example, finance and economics, environmental, natural science, engineering, neuroscience, genetics, security, everywhere. Okay. Security example, event occurrence in log over time, CPU says intrusion detection system, vulnerability. Okay. Neuroscience, brain activity measurement, EEG, fMRI, other techniques. Engineering, speech analysis, you have already seen one example. Okay. So whatever we did for this TVS Motor Company, in place of that, if we can replace the whole system using sensors, because sensor size is decreasing day by day and connectivity is improving, cost is decreasing. So it means in place of that, if we can put sensors in the bike throughout vehicle, so we can monitor different parts of the vehicle. Okay. So people are using it, and then this smart network can actually help the user in order to identify if some problem is there in the vehicle or not. Okay. Or the health is good or not good. Okay. This is the example with respect to time. So you see is SBI stock price. Stock market is a very good example of understanding this time series data set. So with respect to time, we can actually see the behavior of a particular variable, particular stock. This is the mathematical definition of time series. That is the let omega fp be a probability index set. A real valued stochastic process is a real valued function xt omega, such that for each fixed t belong to t, xt omega is a random variable on omega fp. When the index set t corresponds to time indices, discrete or continuous, we'll call xt omega a time series. For fixed t, xt omega is a random variable, but for fixed omega, xt is a real valued function known as realization of time series data. So we typically suppress this omega and we write xt. So we normally denote this xt as the time series data set. Because t we are representing for time. So this x we are collecting with respect to time. So for discrete time series, the set of times t is a discrete set. Then the measurements are typically at the successive time spaced at uniform intervals. Continuous time series are obtained when observations are recorded over some time interval. So xit, if we are using this variable I and t, so I is representing the number of dimensions. So we can actually have two types of dimension of this time series. One is the univariate time series data. Second one is the multivariate. So there are lots of research for univariate and multivariate. So these are the possible areas where you can also guide your student in this area for doing their PhDs. So this univariate, one variable at a time. But for the IoT thing, there will be many sensors. So multiple variable at the same time. These are some of the IoT data for anomaly detection. We want to, water leakage is there in a pipe. Then broken bulbs are there in a smart home. Maybe the gas leakage is there in the ONGC. Then building, you want to monitor the building. So electrical peak, pipe leakage, anomalies in farm data and weather related to farming, agriculture. For goods, you can actually detect congestions are there or not. Why working with time series data is so difficult? I have already told that 1 hour of ECG data is 1 gigabyte. Machine database, then this space shuttle database, 200 gigabytes and growing. So it means gigabyte to petabyte, lots of data sets are there. Since most of the data lives on disk, we need to represent these type of data set. Okay. So now we will see how to actually compress this type of data set if you are having some time series data set. So something is in sequential format. If some significant changes are there, then we should preserve them. Otherwise, we can actually ignore some part. like in video. Okay. Understanding time series modeling difficulty. What is so difficult in this time series? Why we are studying this time series field for IoT, especially for IoT? So this is one graph we have. I normally take this example to explain this concept of time series data. So you see, for a given X, you can have two Ys. Okay. For a given X on the X axis, if you are having some point, so for a given X, you can have two Ys. And that is the most difficult part, because for a given X, if you are having one Y, you can model it, this type of data, for using any system. But for a given X, you can have multiple Ys, then it is very much difficult to predict this Y value, because you cannot say when this Y1 will be there, or you cannot say when this Y2 will be there. Okay. Like in this left hand side, you see there is, for every X, there is single Y. But for the right hand side, for every X, there are two Ys. So for handling this type of situation, what you need some history of that data set. So history is also there. Then you can say for this X, this particular Y1 will be the output, or this Y output. Okay, and that is the same concept we apply in this time series modeling. So what does it mean? We also add history to the data set in order to do the decision making process if we are studying this time series data modeling. So these are some of the major applications like visualization, clustering, classification, pattern recognition, forecasting. Everywhere they are same like your machine learning. This is the example of classification. It can also be converted in form of time series. So you have different kinds of leaves. So the circumference, if you can consider the data set with respect to some origin point, then they can also be considered as the time series data. So this data can be converted to the right hand side, and here you can see that you can actually differentiate between two classes, class 1 and class 2. Okay, so they will have different set of patterns. Okay, so this is one example of dimensionality reduction if you are having time series data set. So how can you do that? Let me take this example. This is, suppose it is a single or univariate time series data, then what will happen? You can divide the whole data set into small blocks, and for every block you can actually compute the average value, and then you can represent the whole time series in form of those aggregated values or average values. And also at the same time, if you want, you can represent them using some symbols A, B, C, D, E. Okay, then you can compare that representing using symbols or aggregated value is actually consuming less storage as compared to the original time series. Okay, so suppose this C is there. So there is a small, suppose 10-second audio is there. So you can take the average value, put it here. So in place of that 10-second, we are representing it using one value. Okay, this 10-second is very large. And those data set which are those average values which are very much near, you can represent them using a single symbol. Okay, so every symbol is representing actually a similar range. Then there are different methods which says that now we want to represent everything using 0 to 25 values. Okay, and we can extend this. We can extend this. So in place of taking this average value, can we take average value and minima and maxima also in order to better represent the system? Okay, so that is the extension of this symbolic aggregate extension. Okay, so we can actually, in place of this only one average value, we can take the minima, maxima and the average value. So that is considered to be much better as compared to only taking the average value. So dimensionality reduction can be done in form of representation, also in form of maybe we can apply some this PCA based algorithm also in order to reduce the dimension. So what is similarity? So if you have some matrix with using some set of integers or some set of symbols, then you can actually detect which are near, which are far. So it means for different type of time series data, IoT data, you can actually identify which are similar, which is not similar. So suppose you have deployed sensor in your home and you are capturing at the same place. So all the sensor will produce similar type of data set. And then if sometime what happen if they are not similar, then this sensor is not producing similar type of behavior. It means either there is some anomaly, maybe that sensor is failed, or maybe some another things are there, or maybe that sensor has detected something which is not normal. Okay, so this similarity measure is always very important in order to detect the anomaly. So for similarity, there are different set of algorithms people can use. Similarity at the shape level, similarity at the structure level, for clustering purpose, for identification and other things. Normally we apply this distance based method in order to detect the similarity between two maybe time series data set. Okay, so added distance is there, then maybe the normal Euclidean distances are there. Okay, so like you see, this is some data set hierarchical clustering example. So we can actually apply different kind of latest algorithms in order to find out the similarity between the data set. Okay, because for different type of complexity, if you have very good system that can actually detect the similarity, then that will be the best system. So here you see that we can actually, the peaks, number of peaks are 5, then 5, we have clustered them together. Then this is 4, then this is 3. Okay, they are clustered them together. Then this is 4 clustered together, then 3 is there. Okay, but if we are having better system, we can actually have better representation also. Okay. So there is a concept of dynamic time warping also. Those who are working in the speech processing area, they should go into the depth. So there is one matrix profile. This is again a latest research which I am telling you for exploring this area of IoT. So matrix profile, this research has been given by Michael A. Then there are many authors. Okay, so this matrix profile. So matrix profile is a data structure that annotates a time series. Okay, so we can run a sliding window across the time series and then we are doing some processing. So matrix profiles tell us the nearest neighborhood information of every subspace. And this we have implemented and we have found that it is giving us better result as compared to earlier methods. Okay, so this matrix profile you can explore later with details. Okay, this is some gun data time series chain. So whatever IoT sensors you are having, they will actually give you data set in this particular form. So recently I actually supervised one PhD thesis on this time series application, representation and forecasting. So my student, she has developed, because these days this deep learning concept is everywhere. So we have also developed a couple of algorithms related to deep learning for time series data analysis. Okay, so normally for any deep learning, you can have architecture like this. There is a concept of convolutional neural network, and then there will be concept of this feature extraction, then classification. So earlier what was happening with the neural network was, first task was to process the data set to identify, detect the features from the data set. Then you are giving the whole data set into the machine learning algorithm, and that was classifying or functional approximation or whatever tasks you want they were doing. Now what is happening, this feature extraction, denoising, all these part people have integrated with this classification part, they have kept together, and that is actually had taken a new shape of this deep learning. So in the earlier layers, actually feature extraction process is going on, and the later layer actually machine learning is going on. So you have handled into one form, and then you are using the whole system in order to predict for the feature values or whatever is your task. Okay, so the same thing we are doing here. So what are the possible challenges, time series application challenges or IoT challenges? It always grows every time you are getting the data set, making big data. So it means you should also explore the field of big data analytics. Too frequent writes, not so frequent reads. So write is only when there is some significant event. And then you are writing to the database, you are not continuously reading it. When are you reading it? continuously when you are doing some real-time monitoring. Reads are for analytics, mostly focused on data point within 1 to 2 weeks. Now see the difficulty. Time series dataset, we have already said that you should have the history also in order to predict the future values. At the same time, what we are saying, so for generating the history, it means you are saving the data set for a continuous time, then you are using the whole system for prediction. Now, at the same time, what we are saying that your system should be able to predict or to be able to make the decision making process in real time. So real time, then also the data set storage. So all these are actually depicting the complex situation. So reads are for analytics, mostly focused on data points within 1 to 2 weeks. Suppose some particular smart city is there and maybe the pollution level is increasing. So that is actually giving you sufficient time in order to process that using 1 to 2 week data. Then you can take corrective measures and so on. Okay, maybe the rerouting the persons who are traveling through that route, maybe the number of vehicles you can reroute from that place. No big vehicle will be there in that particular region. So these type of precaution we can take in order to reduce this pollution level. But if suppose somewhere if there is a fire, so it means you have to make the real life decision making in order to safeguard from that particular situation. Then old data takes unnecessary disk and index space is again a major concern. Then smaller database is always a good thing because you have a bigger database. So earlier you were extracting the feature, then storing it. One thing is original data storage, very huge. Collecting the feature, storing it, again huge. Then cloud to fog, local database you will store there because the speed again is a major concern. Again and again going to the cloud, then getting the data. Security or privacy is also major concern. Okay, so it is always better to store at the local place in the fog. Now, there should be some intelligent method we can also apply in order to only store the important part, not the other features, all the features. Okay, so all these things are there where you can actually apply your own things. New methodologies which you can develop in the near future. So smaller database will definitely consume less CPU or memory, smaller machines, and definitely the overall system will have lower bills. Okay, so I think this is sufficient for my talk. Now we can interact for half an hour. Whatever question you want to ask related to this intelligent based IoT systems. Okay, I can answer.
So there is one question written in the chat box. The question is for flood monitoring, which algorithm is best?
Yes. Slides are not changing.
No, it was actually you were discussing one slide for that was forest monitoring. So I think they were considering that slide is not moving.
Oh,
but it is not a problem, sir.
Okay. So for flood monitoring, which algorithm is best? Now for flood monitoring, what exactly you want for flood monitoring? Means what is your objective? What type of monitoring you want to do?
So once again, I just mute all the participants so that
yes,
they
please
can
unmute all of them.
Yeah, yes, sir.
So that they can interact, they can ask.
Now, if anyone is having any question, as one has, so they can mute themselves and can ask their question.
See, flood monitoring, we did some work for local administration. So some rivers are there, nearby rivers. And what happened is there are many builders who were actually doing this, making their buildings for sale purpose. Omax City is there, then many others were there. So they have taken nearby areas of the river and then they were developing the buildings. So somebody has filed one case in this High Court Allahabad, and then they asked those builders to stop the building construction there because they were telling that during the flood, this river was expanding up to that particular point. So this Omax City, whatever the new building is there, that will come under this flood region. So what was our target? To create a contour at the both side so that we can actually give the on the map, like this will be the region for the flood based on the past history. Okay. And then because this flood, if it will come immediately. So if you are deploying the sensors, maybe you can monitor it for the level of the rain or the level of that water level of a particular river. Then based on that, you can actually detect if it is crossing some particular limit, then you can detect that it can go up to this region. But that history you have to include from the past information, then only you can predict. Now, algorithm, as far as algorithm is concerned, suppose you have created different labels using IoT sensors, then you can identify like if this is the level of the water, then it will reach up to this point. So no need to apply any algorithm. You have to do it by your simple algorithm, like this has happened in the past. So it will go up to this point. Always use algorithm when the situation is very complex and you cannot solve using a very simple method. Because for real life situation, as far as you are using the most simple algorithm or most simple method in order to solve the problem, that is known as the best solution. Okay. Otherwise, you can apply different type of algorithms for this monitoring or prediction. Okay. Prediction for the contour maybe, or prediction for like this was the level, then this will be the output. Up to that level, it can reach the water level. So as per the problem, if you want to classify, actually you want to segment the region. Okay. So for segmentation, you can apply any algorithm based on time series type of algorithm. Past history you can include, and then you can actually predict. So I think this time series will be best suited data for your flood monitoring. Okay, but still algorithm is very much widely applicable. We have a number of applications. You can use any algorithm for a particular task because all the algorithms are specific to a particular task. Okay, so if you clarify more about your problem, then I can exactly give you the exact algorithm like this you can use. Or maybe later on you can also contact me if you want.
Definitely, sir. If there will be any later on query comes to me, then I will forward it to you. So
Okay.
no problem in that, sir.
Any other question? You can ask any question related to this
Yeah.
machine learning.
So
So IoT is
yeah, please.
IoT
So
is not alone system. Actually, intelligence you have to build. That's why all these areas are integrating together. So IoT is the sensor part, the hardware part, embedded system part. Then coming to this intelligent machine, the deep learning, machine learning, that is another part. Then third part is the cryptography or information security. So all these three are now combining together for the future thing. Okay. Yes, sir.
So if anyone other having any doubt, so one can ask or one can write in the chat box. We'll wait for 2 more minutes.
Yes,
So
you can ask anything.
yeah.
Maybe I can get some questions for my future work.
Anyway, so sir, if there will be any doubt later on, so I will forward it to you.
Okay.
So, sir, it was a very nice session taken by you as we get a new area like you have explained very well. IoT can be help in the field of forest monitoring also. So we get an idea to work in the field of. So definitely it will going to motivate all the participants and they get an idea how to bring some new way out from this IoT technology. So I think all will get benefit from your nice lecture, sir. So thank you very much, sir. If there will be any doubt later on, so I will definitely forward it to you.
Okay. Thank you so much. Thank you.
Thank
Thank
you
you
very
all
much,
the
sir.
participants for
Thank you,
not asking questions.
yeah.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
I can leave the meeting now.
Yes, sir. Please.
Okay, sir. Thank you.
So all the dear participants, there is one more announcement to all of you that we have a next session from 12:30 onwards. So we have a small technical session followed by a human values session and then followed by your assessment test and your feedback session. So after that only you will get your participation certificate. If you do not participate in the assessment test, then definitely you will not gonna uh, get your certificates. Okay. So kindly make sure that all of you have to attend the assessment test. So kindly connect from 12:30 onwards. Okay. So we will have a small sessions from 12:30 onwards. Then we'll have a assessment test. Okay. So thank you very much. Till then, have a good day. Bye bye.